Hi everybody. In this video, I'm going to teach you how to simplify radicals. So the lesson is titled Properties of Radicals, and you'll recall that this is the radical, the square root symbol. So to simplify, let's write down a couple things. To simplify a radical, number one, we can't have any perfect squares left in the inside the radical. No perfect squares. Just like when we simplify a fraction, we can have no common factors. When we simplify a radical, we can have no perfect squares. Another biggie is no radicals in the denominator. And then the third is no radicands. And you'll recall that the radicand is the number inside the radical. No radicands contain fractions. Okay? Let me give you a couple examples and show you how to do it. Let's start out with the square root of 98. Now I know the square root of 98 is not a perfect square, because 98 is not a perfect square. But there's a perfect square in 98. So you have to think in terms of your perfect squares. And when I divide by 2, I end up with 49 times 2. So the 49 is a perfect square, class, and it must come out. So when the 49 comes out, I take the square root of the 49, and it's 7. And that's the answer. So that is how you simplify the simplest of radicals. Let's try another one. Let's try 24. 24. Square root of 24. Well, that's 6 times 4. I mean, it's also 8 times 3, but neither 8 or 3 is a perfect square. In this case, 4 is the perfect square, and that has to come out. So when it comes out, it turns into a 2 root 6. Let's try it when we have a variable. Let's say I want to find the square root of 9x cubed. Okay, well, when I think of this, I know 9 is a perfect square. X squared is a perfect square because any even numbered exponent for a variable is a perfect square. So x to the third is x squared times x. So now 9 has to come out. It's a perfect square. X squared has to come out. It's a perfect square. So in the front of the radical, I have 3x, and inside the radical remains an x. Let's try another one. How about the square root of 12x to the fourth? Okay, again, 4 times 3 times x to the fourth. Circle the perfect squares. They need to come out. So 4 comes out, turns into 2. X to the fourth comes out, turns into x squared. What remains inside? The 3. So that's how you simplify radical expressions of that form. And that's you're going to have about, 10 or 15 of those to practice. And you can see they go pretty quickly. Okay? Now let's practice some that are fractions. So let's say we want to simplify 15, the square root of 15 64ths. We want to simplify the square root of 15 over 64. Well, what I want to do here is separate it into 2, and we're allowed to do that. Square root of 15 over the square root of 64. Well, the square root of 15, that's an irrational number. That's just the square root of 15. It cannot be simplified. But the square root of 64, we know, is 8. So that is simplified. Because if you remember or recall our 3 kind of objectives: no perfect squares, none. No radicals in the denominator, 8 is all by itself. And no radicands contain fractions. Well, the only radicand is 15, and it does not contain a fraction. Okay? Let's try another one of those. How about this one? 81 over x squared. Well, the square root of 81 over the square root of x squared is 9 over x. Okay? And here, you know, obviously 9 times 9 is 81, and x times x is x squared. So that's how you simplify radicals in that form. I'm going to make another lesson video for you on rationalizing the denominator. So look for that. Thank you.